Welcome to Penrose Learning, where we make understanding easy.
You start by picking hardware. Use a Raspberry Pi or ESP32 because they give native Wi-Fi and GPO without Arduino. Install the OS, enable SSH, and plug in a USB or I2's microphone and a speaker so you can test audio immediately. Once done, wire the motor driver and power supply to your motors and verify the chassis moves freely. Make sure to label GPO pins for sensors and actuators. This saves time when you begin software integration. Next, you turn speech into motion. Install a local recognizer like Vosk or configure a cloud API if latency is acceptable. Train or configure a small intent set. Move forward, turn left, stop. Then write the bridge. A lightweight Python daemon listens to transcriptions, extracts intents, and issues GPO pulses or serial commands to the motor driver. While doing that, implement watchdogs and sensor feedback so commands stop on obstacle detection. Finish by polishing control. Add command queuing, debounce voice triggers, and confirmation prompts for risky actions. Test in different acoustic environments and under battery load to catch performance drops. Tune microphone gain and recognition thresholds accordingly. Once integrated, package the software as a service that restarts on failure and expose a simple web UI for manual override. If something goes wrong, enable verbose logs and rely on a physical kill switch so you can stop motion immediately while you inspect failures.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.